The ghost of the Russian Empire lives in a stone that doesn't really exist anymore, or at least it doesn't exist in the way that the legends say it should. If you walk into a high-end jewelry store in London or New York today and ask to see an Alexandrite, the jeweler will likely take you to a back room, put on white gloves, and show you a gem that is a teal blue in the daylight and a purplish amethyst in the evening. They will tell you it is rare, they will tell you it is valuable, and they will tell you it is a color change miracle. They aren't lying to you, but they aren't telling you the whole truth either, because the stone they are holding probably came from a mine in Brazil, or a riverbed in Sri Lanka, or a deposit in Tanzania. While it is chemically the same material, it is not the stone that started the legend, and it is not the stone that drove the Tsars mad with jealousy. The true Alexandrite, the original material that captured the imagination of the Victorian world, is a dead lineage, a geological bloodline that was extinguished over a century ago. It came from a single set of mines in the Ural Mountains that were discovered in the 1830s and were effectively exhausted by the time the Bolsheviks stormed the Winter Palace. The Earth gave us a tiny, fleeting window of perfection, a few short decades where the chemistry of the crust did something statistically impossible, and then it slammed that window shut forever. Tonight we are talking about the Tsar's Chameleon, the stone that swallowed the yellow light of the sun to reflect the blood of a dying dynasty, and why the physics of this stone is just as tragic as its history. To understand the profound melancholy of this stone, you have to transport yourself back to a very specific time and place, the Tokovaya Valley in the Ural Mountains in the year 1834. The Urals were the treasure chest of Russia, a rugged frozen spine of rock that separated Europe from Asia, and in the early 19th century, they were in the grip of emerald fever. A peasant charcoal burner had discovered green stones in the roots of a fallen tree a few years prior, and suddenly, the Imperial court was obsessed with finding the Russian emerald. It was in this chaotic, mud-soaked atmosphere that a Finnish mineralogist named Niels Gustaf Nordenskiold was scouring the riverbanks, looking for the green fire of the emerald. On April 17, 1834, he found a cluster of crystals in the mica schist that looked promising. They were dark, they were green, and they had the hexagonal structure that hinted at beryl. He put the stones in his pocket, believing he had found a high-quality emerald specimen that would please the authorities in St. Petersburg. But the geology of the Urals is a trickster, and it had prepared a surprise that would confuse the scientific world for years. That evening, as the sun dipped below the pine trees and the camp settled into the twilight, Nordenskiold took the stone out to examine it by the light of the campfire. He expected to see the lush, mossy green of an emerald illuminated by the flames, but when he looked at the stone in his hand, the green was gone. The crystal was glowing with a deep, intense raspberry red, the color of fresh blood. He must have thought he was going mad, or that he had somehow swapped the stone in his pocket, because minerals do not change their identity just because the sun goes down. But when he looked at it again the next morning under the cold blue light of the Russian dawn, the stone was green again. It was a miracle of timing because the discovery coincided almost exactly with the 16th birthday of the Tsarevich, the future Tsar Alexander II. The colors of the stone, green and red, were the official colors of the Imperial Russian military, the colors of power and patriotism. Count Lev Perovsky, a noble and mineral enthusiast, realized the propaganda potential immediately and named the stone Alexandrite in honor of the young prince. It became the talisman of the Romanovs, a national symbol that represented the duality of the Russian soul, green for the fertile vastness of the land, and red for the blood that was so often spilled to defend it. But the history of the stone is inextricably linked to the tragedy of the man it was named after. Alexander II was known as the Tsar Liberator because he was the one who finally freed the serfs, attempting to drag Russia into the modern world. But like the stone that bore his name, his life was defined by a shift from hope to violence. He survived multiple assassination attempts, hunted by revolutionaries who saw him not as a liberator, but as a tyrant. In 1881, the prophecy of the Red Stone was fulfilled when a bomber threw an explosive at the Tsar's carriage in St. Petersburg. When Alexander stepped out to check on the wounded, a second bomber threw another device at his feet, shattering his legs and bleeding him to death in the snow. The stone that turned red in the darkness had become a grim omen for a dynasty that was heading toward a violent extinction. But let's step away from the romance and the bloodshed for a moment to look at the why. The magic of the Alexandrite isn't magic at all. It is complex quantum physics hiding in a crystal lattice. To understand why this stone shifts, we have to look at the invisible war happening inside the atoms. Alexandrite is a variety of the mineral chrysoberyl, which is chemically beryllium aluminum oxide, Bl2O4. Normally, chrysoberyl is a boring, transparent, or yellowish-green stone that nobody really cares about. But the Russian material was born in a geological soup that contained a specific intruder, chromium. Chromium is the coloring agent of the gods in the world of gemology. It is the same element that turns clear corundum into a red ruby, and it is the same element that turns clear beryl into a green emerald. But in Alexandrite, the chromium is put into a very difficult position. It is forced to replace the aluminum atoms in the crystal lattice, but the chromium ions are slightly larger than the aluminum ions they are replacing. This creates a stress in the crystal structure, a tension that changes the way the electrons orbit the nucleus. The chromium ions create what physicists call a color center, acting like a very specific, very picky filter for light. This is where the Alexandrite effect happens, and it is all about the absorption spectrum. If you look at the light spectrum of an Alexandrite, you will see a massive absorption band right in the middle, around 580 nanometers. This corresponds to the color yellow. The stone swallows yellow light greedily, absorbing it completely. However, it allows the wavelengths on either side of yellow, the blues and greens on one side and the reds on the other, to pass through almost equally. This is the key. The stone is a balanced transmission filter. It is sitting right on the fence between being red and being green. The deciding factor, the thing that pushes it off the fence, is the light source itself. The human eye is a lazy observer. It relies entirely on the light available to tell it what to see. We have to understand that white light is a myth. Every light source has a color temperature and a specific spectral power distribution. Daylight, the light from our sun, is extremely rich in high-energy blue and green wavelengths. It is a cool light. When sunlight hits an Alexandrite, the stone has plenty of blue-green energy to transmit. It floods your eye with green light, and because human eyes are biologically evolved to be most sensitive to green, to spot predators in the grass, our brain screams, green. The red is there, but it is drowned out by the intensity of the blue-green signal. But the world changes when the sun goes down. In the 19th century, the night was lit by candles, oil lamps, and later incandescent tungsten bulbs. These are black body radiators that burn at a much lower temperature than the sun. Their light is weak in blue and green energy, but incredibly rich in low-energy red and orange wavelengths. So, when you hold that same Alexandrite next to a candle, the stone looks for green light to transmit, but there is none. The candle isn't giving it any green to work with, but the candle is pouring buckets of red light onto the stone. The Alexandrite happily transmits that red light, and suddenly, your eye sees a deep raspberry crimson. It is a balancing act of physics where the stone doesn't actually change. The world around it changes, and the stone merely reflects the reality of the fire you are standing next to. It is the ultimate chameleon, not because it hides, but because it reveals the nature of the light source. It tells you whether you are standing in the kingdom of the sun or the kingdom of the flame. There is also a phenomenon called pleochroism involved here, which is the directional color of the crystal. Chrysoberyl is trichroic, meaning it has 3 different optical axes. If you turn a raw crystal in your hand, you might see flashes of orange, purple, and green all at once, depending on the angle. But the true drama, the famous color change, is that dialogue between the chromium and the light source. The tragedy of Alexandrite is that the geology required to make it is almost statistically impossible. To make Alexandrite, you need 2 specific elements to meet, beryllium and chromium. The problem is that these 2 elements live in completely different neighborhoods of the Earth's crust, and they almost never speak to each other. Beryllium is a lithophile element. It loves the light, rocky crust, and is found in pegmatites, the crystallized leftovers of granitic magma. Chromium is a siderophile element. It loves the deep, dark, iron-rich mantle, and is found in mafic and ultramafic rocks. For Alexandrite to form, you need a pegmatite, rich in beryllium, to punch its way through a layer of ultramafic rock, rich in chromium. You need a geological car crash. You need the lighter crust to collide violently with the deeper mantle in the presence of water and heat, allowing the fluids to mix and crystallize. The Ural Mountains were the site of exactly such a crash 250 million years ago. The tectonic violence there was unique, creating a Greisen deposit where the conditions were perfect. The result was a deposit of stones with a color change that has never been matched since. The Russian stones went from a grassy emerald green to a deep blood red, a 100% color shift that is the holy grail of gemology. But mines are mortal, they have lifespans, and the lifespan of the Tsar's mine was short. By the early 1900s, the miners were chasing thinner and thinner veins. By the time the Russian Revolution turned the world upside down, the mines were effectively empty. The lineage was dead. The Soviet Union, in its early years, didn't care much for imperial jewelry. They sold off vast amounts of the Romanov treasures to fund their industrialization. Many of the finest Alexandrites were sold to Cartier and Tiffany's in the 1920s and 30s, disappearing into the private collections of American heiresses and European aristocrats. They became ghosts, appearing at auctions only once in a generation. Today we do find Alexandrite in other places. In 1987, a massive deposit was found in Brazil in hematita. These stones are beautiful, but they are different. The Brazilian stones often have a teal, bluish-green color in daylight, shifting to a purple amethyst color in incandescent light. They are stunning, but they lack the stark, military red and green contrast of the Russian material. We find Alexandrite in Sri Lanka, but these stones are often large and clean but muddy. The color change is sleepy, shifting from a brownish green to a brownish red. They lack the snap, the violence of the color change that define the Ural stones. If you see a stone today that claims to be a Russian Alexandrite, you should be immediately suspicious. It is likely a lie, or it is a synthetic. And this brings us to the other ghost in the room, the laboratory. Because Alexandrite is so rare and so valuable, humans have been trying to fake it for a century. We have become very good at growing chrysoberyl in labs using the Czochralski pulling method, where a crystal is slowly pulled out of a molten vat of chemicals. These lab-grown stones are chemically identical to the natural ones, but they are too perfect. They are flawless, they are clean, they change color with a boring electric predictability. They lack the jargon, the garden of inclusions that marks a natural stone. A true Russian Alexandrite often contains tiny flakes of mica or biotite, little fingerprints of the schist it was born in. The lab stones are sterile. But there is an even cheaper imposter that you have probably seen at a grandma's house or in a tourist shop. It's called color change sapphire. For decades, labs grew synthetic sapphire and doped it with vanadium. These stones change from purple to blue, and they are sold as Alexandrite to tourists who don't know any better. But they aren't chrysoberyl, they are corundum, they are a lie twice over. There is a deep, visceral melancholy in holding a true antique Russian Alexandrite. I have held one only once, in an estate jeweler's office. It was small, less than a carat, set in a heavy, scratched gold ring from the 1890s. When I took it to the window, it was a sharp pine forest green. When I struck a match and held it close, the green vanished instantly, replaced by the color of a dying ember. It didn't look like a magic trick, it looked like a warning. You are holding a piece of a vanished world. You are holding a stone that was named after a doomed prince, mined by a doomed empire, and pulled from a hole in the ground that has been silent for a century. It reminds us that the earth does not produce these things for our amusement. It produces them by accident, in violent spasms of chemistry. And when they are gone, they are truly gone. We can mimic them in a lab, we can synthesize the chemistry, and we can grow crystals that are bigger and cleaner than anything nature ever provided. But we cannot synthesize the history. We cannot manufacture the specific geological moment that occurred in the Urals 250 million years ago. The Alexandrite teaches us that perception is relative. It teaches us that there is no such thing as true color. What you see depends entirely on the light you are standing in. In the harsh, unforgiving light of the day, things are green and growing and hopeful. In the soft, dying light of the fire, they are red and bloody and final. Both are true. Both are the same stone, it just depends on which star you are burning under. So the next time you look at a color change gem, ask yourself what you are really seeing. Are you seeing the stone, or are you seeing the spectrum? Are you seeing the chromium, or are you seeing the candle? And if you ever get the chance to hold a real Ural Alexandrite, remember that you are not just holding a gemstone. You are holding the solidified blood of the Romanovs, a frozen drop of history that refuses to pick a side. If you want to understand the physics of light and the tragedy of extinct gemstones, and if you want to know how to spot the difference between a vanadium imposter and the real thing, you need to subscribe to Mystic Apothecary. We don't just look at the sparkle, we look at the spectrum.